This is Miles, Raymond, and Summer with Team 9 giving our presentation on our QuickShare software application. QuickShare is a simple way to share your screen or other streamable content with friends and family. It's a simple web application that allows you to create a hosted room to invite people and stream video and audio from your computer to them. The goal of our application is to be easy to understand. It requires no accounts, no logins, just a room code to join or to share with other people you want to share content with. The reason we built this system is we wanted to create a lightweight screen sharing application that gives users a fast way to connect their screens to other users. This normally would be accomplished by downloading applications like Discord, Zoom, or TeamViewer, which all require users to create accounts. Our website was built with the idea of connecting users fast without the need to create complicated user accounts or to store information on other people's servers.
The primary motivation behind this project is first and foremost that there isn't any easy to use screen sharing application that is as simple as this concept. Our application is built on two primary things, simplicity and speed of access. There isn't anything to install, simply run the application in your web browser, and it establishes a room for other users of your choosing to join. The method of joining is equally simple. A code or an invite URL is provided to the room host, which can be shared to people that wish to watch whatever the other person is doing on their computer. This makes streaming content very easy and requires no accounts or cumbersome applications. One of the primary counterpoints to this application is the Discord app. We are doing something that Discord isn't, which is providing streaming without needing to connect voice to a voice room or chat client on a desktop. Discord makes this cumbersome and difficult, especially if you don't want or wish to set up a Discord account or install it on your PC. An alternative is Twitch, which is extraordinarily difficult to set up for streaming in any capacity. Having to manage a cumbersome piece of broadcasting software is the antithesis of our goals with QuickShare.
Django is a Python-based extensible web server that we used for serving page content and handling interactions between our streaming server and our users. We also built a connection between this and MySQL to handle requests for IDs and tokens. Django is an industry-standard Python web server that makes it easy to add Python-built tools to a web server. SQL is an industry-standard database server that we use to handle host and client interaction with the token ID system. SQL is a fast, well-known, and generally easy-to-use database system that allowed us to be flexible with the token ID system and to implement it quickly and easily.
OpenCV is a computer vision library that we will be using for our system stream handling. In addition, we can use it for both color and compression transformation of images to be broadcast from the streaming server or from the host of the server. OpenCV is a industry standard tool for image processing and manipulation, which will allow us to easily and efficiently capture video from a system.
In our initial application testing, we were using a package called VidStream as a wrapper for OpenCV. We eventually decided to pivot off this as it required an implementation of sockets. This would have added extensive additional complexity to server-client negotiation for establishing a connection between two people to actually stream video to. We discarded this and used some of the underlying packages of VidStream as the basis for our streaming server within Django. Once we realized we could create something called a streaming HTTP response, we were able to send the video feed through to Django itself. This allowed us to streamline our process extensively and to speed up the streaming server quite a bit.
So the software processes that we used for the minimal viable product was a waterfall approach. We took a waterfall approach when developing the MVP because we simply wanted to get a sample product ready for our demo. Our planning stage was when we created our UML diagrams, followed by an extensive coding stage where we developed the main functionalities of the minimal viable product. This was then followed by lots of software testing and debugging to get our demo ready for the TA. Later, for the Django application, we took inspiration from Agile and took a iterative development process where we would develop working software and immediately test it.
So when running our web server, within our code, it starts out in urls.py, which follows the URL, and depending on what is in the URL, it navigates to our quick share app folder, which within that there is another urls.py. And then within this, it navigates to whatever extension in the URL is there, which calls the functions in views.py.
Within views.py, our application is actually the core of our application. Once the particular web page that is being pulled by the server is accessed from URLs, such as join room or create room, our code for both our database and our streaming server is executed. First, our database is executed, which is established within our models.py. This actually generates all the SQL information that needs to be generated and creates our tables, room IDs, tokens, creation date. Once those are generated by the server, then it accesses a piece of code within each of the join and create fields to either create or query the database for a token that allows it to look up the streaming server within a global list stored on the server of all active rooms. This streaming server creates a thread that is executing a function called update. This update function, what it does is it goes in and grabs a video frame from the host or the room host, does a quick conversion, and then stores it within its a particular frame within the streaming server object. What the room then does, if you are joining on it, is that it will request the frame from that particular streaming object and place it within the actual web browser. That is done through a data frame that is created within the join room. And that is handled right here by something called a streaming HTTP response, which is just a very long-winded way of saying we open a UDP connection to the web server, and the web server posts some sort of mixed HTML image data to the actual web browser itself. The create room function is actually very simple. All it does is generate an ID token pair, stores them in the database, and then adds a new room or a new streaming room to the streaming server list, stores the token in the streaming room data object, and starts that stream. And it inserts it into the stream list. Then it returns that our particular HTML template that we have for that room. We also have a couple of templates for our join room. These were all, I believe, created by hand by Summer. They're pretty extensive, but they're all pretty similar. They are stored under the templates for the QuickShare application, and these views are rendered upon request by the actual function when they're called from URLs. And that's pretty much it. Alrighty, so we're just going to hop straight into the demo here. To actually run our server, you would execute the Python command, well, you just open a Python prompt, and tell it to execute manage.py run server. And this will go ahead and fire up the server. It's currently running on a local host, but this IP address or URL could change at any point, and the server would still function just fine. I'm going to go ahead and refresh our pages here just to make sure we actually have live connection. And you can see that our server is serving both those GET requests. This is just because I can't find the favicon, which is a little symbol that would pop up here. The browser always requests it, so we don't have one because none of us can draw. So yeah, it's actually really simple how it works. You just hit this button here, create a room, grab your ID, and open up what would be your client or someone trying to join the room. You would somehow give them the ID code that was created here, and you would simply put it into this field and hit submit. And there you go. You now are streaming live to someone else. And that's it. It's extremely simple, straightforward, and easy to use. There's no gimmicks. This is it.
Some of the must-have features that our team fully delivered were a working homepage, the ability to share a screen, and the ability to join and create rooms using unique IDs and tokens, which you can see through our demo we just showed you.
Some features that weren't delivered were the ability to share a selected screen, so a selected window. However, we sort of discovered that this was kind of redundant because the whole point of our application was to share a full screen. So this is something we disregarded. And we weren't fully able to implement audio capabilities within our web app either.